Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating article from lwn.net about a novel approach to exposing concurrency bugs using a custom Linux scheduler. It's all about shaking those pesky bugs loose.
Sounds exciting. I'm particularly interested in how this custom scheduler differs from existing concurrency testing tools. Is it a completely new approach, or does it build upon existing techniques?
It's a clever blend of old and new. The core idea, introducing randomness into thread scheduling, isn't new. Many tools already do this. But this scheduler, concurrency fuzz scheduler, uses the Linux kernel's sked_extadjet framework to achieve this in a unique way. It's not as fine-grained as some other tools, but that's its strength. It targets gross logic errors, the kind that often slip through the cracks in real-world applications.
So it's less about finding subtle memory model violations and more about uncovering those nasty, hard-to-reproduce bugs that plague developers? That's a huge problem.
Exactly. The article gives a great example. A producer-consumer queue with expiring items. A seemingly simple scenario, yet it highlights how seemingly innocuous pointer copying can lead to catastrophic failures under load. The scheduler deliberately introduces delays and randomizes thread execution to exacerbate these issues, making them much easier to surface.
I see. It's almost like a controlled chaos approach. But how does it actually work under the hood? The article mentions a global queue. Doesn't that create scalability issues?
You're right to point that out. The simplest implementation uses a global queue, which is great for demos, but it's a bottleneck on larger systems. The synchronization overhead between CPUs becomes a major performance drag, potentially even triggering the kernel's soft lockup detector and causing reboots. Yikes!
So it's not quite ready for prime time in production environments then? What are the limitations?
Currently, it's more suited for individual developers debugging intermittent issues on their workstations. It introduces significant performance overhead, running tasks much slower than usual. The developers acknowledge this and are working on improving performance and scalability. They're exploring things like local queues per CPU to alleviate the synchronization problem.
That makes sense. What about future directions? Are there any plans to make it more intelligent, perhaps by analyzing application memory?
Absolutely. The developers are considering adding more sophisticated features, such as allowing applications to provide scheduling hints. Imagine being able to preempt a task during a critical section. That would be incredibly powerful for catching synchronization bugs. They're also looking at simulating memory latency and other sources of erratic behavior to broaden its effectiveness.
This sounds like a really promising project. It's exciting to see how sked_extend is enabling more innovative approaches to concurrency testing. It's a testament to the power of open source collaboration too, with developers from OpenJDK and Meta working together.
Precisely. And that's a great point to wrap up. The concurrency fuzz scheduler is a fantastic example of how open source tools can help us tackle the ever-increasing complexity of modern software. It's still early days, but the potential is enormous. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.